All right. Welcome back. We're at the Shop Class Podcast. Luckily, we got an awesome guest tonight, and we have a regular, and they have the great topic about the blower door test, which I call the red door of truth, which is kind of overdone by now. But keep in mind, I am not a house builder, okay? I'm a car guy that is really interested in the science of building science. And that's so let me introduce who we got. Sam Myers, how you doing?
Good. Thanks for having me on.
All right. And Sam's from Retrotec, which makes a blower door, and it's a red door, obviously. Then we got our regulars with perfect timing. We got Matt Bloomquist. How you doing?
Hello.
And we got Nick, the
Present.
tech ed fireman. How you doing?
Good, yep.
Nick, we haven't seen you in a while. How you been?
Good. We had a vine drill last week with the fire department, and I had to run it, so I couldn't not be there.
Okay. So before we get into any thermal breaks, which is my favorite term, let's talk to Sam. Sam is in his lab, which is, I'm so excited. I had no idea that Sam would have all the equipment. But just to prep this, just in case someone doesn't know what a blower door test is, just think of it like you're gonna measure how much your house is losing or leaking. But Sam knows how to explain this better than I do. I'm just kind of making it layman's term for the. Actually, if you're an engine guy, it's like a leak down test in a way. If you're an engine guy, pressurize the cylinder and then you look for leaks. And actually, you could use a smoke machine too if you wanted to. That would be pretty cool. But anyway, so you're looking for leaks in the house. Treat the house like a science experiment. Let's go to the envelope. Sam is in the envelope right now.
Yeah. So I'm Sam Myers. I'm with a company called Retrotec. We make building envelope and HVAC diagnostic tools, specialize in air tightness testing and airflow measurement. So the blower door is one of our core products. I'm our in-house building scientist and trainer. So I guess really to kind of kick off with, I think it's important to kind of cover why we care about this stuff, because up until recently, you really haven't heard much about this, especially if you're a home builder or even more importantly, a homeowner or someone looking to buy, why this stuff matters. So, historically, when we built houses, back in the early days when, this country was founded, the primary purposes of a house were to keep us dry, to keep us out of the elements, maybe keep us warm if we have a fireplace, and to keep intruders out. But later on down the road, whenever we brought in air conditioning, we really kind of had to rethink how a house works. So this is kind of shop class meets physics class a little bit here. So especially if you live in a humid environment. I live in Wilmington, North Carolina, so we get really high humidity here throughout most of the year. And if you cool down something, moisture is going to attract to that. It's the same thing if you leave a glass of ice water outside, what's going to happen? It's going to condense.
Yeah, you're going to get the condensation on the outside, like a beer can.
We run into the same issues in houses or any building, really. Once we start to cool things down on the outer skin of that building, especially if it's leaky and not well insulated, that's where we get mold growth and things like that. And if it's a wood structure, we can get rot. So the four main reasons why we really care about air tightness is the durability of the house, the health aspect to it, comfort, and then energy use. So those four things are really related when you build a nice airtight house with the proper ventilation and mechanical sizing. All these things have to work. So the blower door is what we use to measure air tightness in a house or really any building. And one way I like to kind of put this is, if I put a laundry basket in front of you and I put a Yeti cooler in front of you, which one are you going to ice your beer down in?
Right. Yeah.
Houses are the same way. We want our houses to be just one monolithic skin with good insulation right on top of that air barrier to keep us comfortable and to keep that house standing for a long time.
Okay, cool. The house I rent right now, if there's a storm outside, I can actually, and then you drop the piece of paper, it would move. I These guys have heard me say that 1,000 times, but there is a lot of leaks, and the walls are cold in the winter. It's terrible. And yeah, I probably don't need to do a blower door test to know that this thing has no insulation, you know? However, if you're getting serious about your house or building, you know, this is it right here. Now, usually we ask our guests the most important question, which is, did you have shop class growing up? But before we get into that, wait, let's say hi to Duke right here. Duke, how you doing?
Good. What's going on?
All right, man. We're doing building science tonight.
I've seen that, the red door of truth.
Yeah. So, Duke teaches middle school shop class. Nick teaches high school, and obviously, you know, Matt Bloomquist teaches high school, but on site, on the job site, which is pretty cool. Now, when it comes to this this blower door, are you able to run through? I mean, you don't have to do it yet, but you're able to run through all the different scenarios with that lab behind you.
Yeah, sure. We can run through and just kind of show the gist of how it works.
Oh, that's awesome. All right, so let's get to the main question. Did you have shop, and it's okay if you didn't, but did you have shop class growing up?
Yeah, I did. We definitely didn't go into the detail of building that a lot of these guys that I've seen post on Instagram go into. Really just some of the basics, how to use tools, how to put some things together and things like that. But we definitely didn't build a house, that's for sure. And we definitely didn't build a house and run a blower door test and get it down to 0.4 ACH 50. I mean, that's awesome.
Yeah, that's big. We'll pull up Matt's Instagram and we're going to go through that whole thing. Now, let me ask you the second question of the podcast, which is, like, how did you get to where you are now? Like, did you start out doing this, and what was your kind of journey like?
Yeah, so I went to college here in Wilmington at UNC Wilmington. When I came out of the public high school that I was in, it did not prepare me for that at all. So I was able to keep my head above water, got through it, kind of hit the real world after that, and then realized, all right, I've got to do something else. So I was living in the Outer Banks for a couple of years, doing vacation rentals. So every Saturday and Sunday, I would deal with a family coming in from 9 hours away with a minivan full of kids. And so that got old after a while. So I wanted to go back to school. And East Carolina University had a Master's of Science program in sustainability. Built environment was a track there. And luckily enough, I sit down at the first meeting and they said,
Sam, what was that last part? The built environment. What'd you say? I couldn't hear you.
Yeah, so that was the concentration for my master's.
Oh,
degree,
the
was
track.
built environment.
I got it. The track.
Yeah.
Okay.
So they said, well, we got this grant from the EPA to study energy consumption of coastal vacation rental homes on the Outer Banks. Are you interested in managing this? Like, yeah, sure. That sounds great. So that was really where I got my first taste in building science, investigating what makes houses consume energy the way they do. And so we got a grant to go and investigate 30 different houses and write a report. And then, once I got my master's and left, I worked for a company in Raleigh, North Carolina called Advanced Energy. And I worked as a building scientist there for about 5 years. So here I am, fresh out of school with a master's degree, crawling under houses and crawl spaces and hot attics and things like that. I loved it. It never really crossed my mind to think about going into a trade. That's just not the direction that I was really pushed into. But looking back, I think it's something that I really would have enjoyed. But I do enjoy working with them now. There's pretty much any trade in the building industry I'm able to work with on to solve certain issues. But after doing all of this type of testing, writing standards for different programs, eventually Retrotec picked me up, and I've been with them now for about 4 years. So I travel the country. I teach at conferences, at training events. I go out into the field and help customers with some complicated tests and things like that. So it's a lot of fun. I enjoy it.
That's cool, man. That's a good pathway. So did you use the red door of did you use the blower door test when you were doing these audits back in the day?
I did not. That's one thing looking back, I wish we would have spent some of that funding on, but that was before I really knew about what that was. We didn't really have a good educational resource in our department to really teach us how to do it either. So when I left East Carolina and went to Advanced Energy, I mean, that's what we dove into immediately. I mean, they use blower doors every day to verify certain things. So they have a program called System Vision that's used for pretty much every affordable housing project in North Carolina. And they're able to guarantee comfort and energy consumption. You write an energy model, you create that, you see what the leakage is going to be, you model that out, you test it to make sure it's going to be there, and really you don't have any problems after that. So I got into helping to write those standards and teaching contractors how to do this, to be able to meet those goals.
So that's in North Carolina, System Vision?
Yeah, they still have it. It's administered by Advanced Energy. They're a energy engineering and consulting firm.
System Vision. And oh, here it is. And is that's using the blower door? Is that what you did or no?
It's a big part of it. There's actually some pretty nice resources on that website. If you go to systemvision.org and go to tools, we wrote up some manuals on, you know, how to install a duct system to where it's going to be super tight. How to properly install an air barrier, where your problem areas usually occur. So we wrote a lot of that stuff, and it's really free for anybody to grab.
Where's the tools?
Let's see, unless they changed it. Let's see, are you at
Oh, yeah.
System Vision?
You see my screen, right?
Hit visit site under System Vision. Scroll down a little bit more over on the left side. There you go.
Got it.
And then I think you should be able to see, they changed the
Process
website pretty recently. Let's see.
Oh, there we go. Tools. Got it.
There we go. So the digital manual, we use HERS raters whenever we couldn't, test everything out. But there's some different checklists and things in there too to look over. And this is primarily for new construction.
Oh, wow. This is cool. Oh, look at that. They got a cross section. That's awesome.
Yeah. So crawl
this is
spaces are a big thing here. So that's one thing that we had to get right. We completely did away with the ventilated crawl space. It's not something we ever allowed. So you either had to supply some conditioned air or have a dehumidifier run. But,
okay. So, I see. Instead of vented, like just open to the outside, it's part of the envelope. Is that what you're saying?
Exactly. Yeah, because one of the problems with vented is, it can be 90 degrees outside and 90% humidity, but it's naturally going to be cooler in that crawl space. And so whenever you have that same amount of humidity, it'll immediately go to 100% in that crawl space and start condensing. And that's when you have all kinds of rot and mold starting to happen. So it's really, you're really rolling the dice on whether if that design is going to work or not. So we did away with that entirely.
Wow. Okay. So you're now responsible for it. It's a part of the envelope. And I'm only able to understand that because I watched Matt do that with his house. And so I wouldn't have known any of these things, like to me, I'm like, it's just a house, but it matters because you can feel it you can feel it, at night when you're conditioning. And then also you could feel it in your energy bill. And then also, you'll get rot in there.
And that's air you're breathing in. So especially with the stack effects that we have in the winter, air moves from bottom to top. So it's going to pick up all that nasty stuff that's in that crawl space through leakage to the floor. And eventually that's what you're breathing in. So we want to keep that separate and kind of keep it its own space and have its own little climate down there to keep that under control.
Right. So starting at the foundation, that's a good place to start.
Yeah.
Interesting. This is pretty cool. So now that's kind of like where you started. And now from there, you help write some of these manuals, but then from there you broke off and you're now part of Retrotec, right?
Yeah, I'm actually a contractor for Retrotec. I have my own company, but I primarily work for Retrotec.
Yeah,
pretty much 100% of the time.
That's cool.
Hey Sam, where do these when did they start using these blower doors?
That's a good question.
Man, Retrotec's been around making blower doors since 1980.
Were they the first ones?
They were not the first. There were some other companies before that are no longer around. And now there's really just two manufacturers that are making blower doors now. They both started up around the same time.
All right, and now do certain states require a blower door test, or is it just like a feather in your cap?
Yeah,
know?
there's different states that do, and the standards, the air tightness standards vary from state to state, and then sometimes there's certain jurisdictions in some states that require it, where the rest of the state won't. So it just depends on where you are.
All right, nice. I don't, Ron, go back a little bit. I don't know if I agree with the choice of framing lumber on that picture, but that's okay. I'll let you get away with it.
Yeah, where's the thermal break? We need a T-stud, baby. Man, the podcast has us trained. You gotta understand.
Yeah.
We're all in here. We're all in on Mark Willie and the T-stud. We like everything efficient here. We're going all in here. We're
Right here.
Oh, right on.
there you go. Nice. Cool. So I have mine is that, I don't know if mine's over here, but it's at the school, I think. Okay, so yeah, because that's a good question, Duke, because it's kind of like I never heard of this stuff growing up, but I also didn't build houses, you know. Yeah. So now just so people understand what's going on, do you want to walk us through, like, let's say someone has a house, is the first thing they would do, let's say it's not a new it's not a new construction, it's an existing house. Is the first thing they would do an energy audit before they start opening up walls and stuff like that? Or is there some step before that?
So, okay, so this is an existing home that's about to get a rehab.
Yeah.
Okay. Yeah. So it's nice to be able to do a pre and post test. So you want to be able to see how much you improved. So you'll do that initial test.
Like a baseline.
Yeah, there's some things to look out for. For example, you can either put the house under a negative pressure or a positive pressure, so you can depressurize it or pressurize it. Either one is fine. I prefer to depressurize because all of your dampers for your bath fans, your kitchen exhaust, they're getting pulled in instead of getting blown outward. However, if there's a wood burning fireplace, you want to check and make sure there's no ashes in there because you will pull that in. I've done it. It's not fun. I've done it in my own house, so it can create a mess. So make sure that fireplace is cleaned out. And just a good rule that I like to follow too is if I know that there is mold growing somewhere on the air barrier of that house, I don't want to depressurize it and pull all those mold spores in. That's another scenario where I'm going to flip that fan around and push that stuff out instead of pulling it in. And then the one scenario where we say to never run a blower door test is if the attic has vermiculite insulation.
Vermiculite?
So the stuff they used back in the day that has asbestos in it. It kind of looks like a crushed up gray denim. There was a big lawsuit. The company, the manufacturer was called Zonolite. So there's actually a Zonolite attic insulation trust. So that'll actually help pay for some of the remediation if you run into that. But we say not to even pressurize the house at that point because you can still disturb it and then it can fall back down into the wall cavities. So it's always important to check up there and see what you got before you start running a fan if it's an existing home that's got some age on it.
Oh, wow.
I don't have to worry about that. I don't have any insulation in my attic. I can
start from scratch.
I can look from my attic to my basement, right through the walls.
Oh, I'll tell you what. I'm looking at this now. I bet you this is what's in the attic of the house where I live now. Look at that.
That explains a little bit.
Yeah. Well, I also work in a basement all day. I'm sure that's not helpful either. Yeah, this is like crushed up. What'd you say? It's like crushed up granular.
Yeah, it's just like a gray, crushed up looking, just granular material. Yeah.
I'm not surprised. Whenever I see this stuff, I'm like, yep.
Yeah, you definitely want to get that remediated before you start manipulating the pressure on the house to pull that stuff in.
All right.
That fan runs hard enough to pull that out of an attic?
Yeah, so what we're doing is we're testing the house to 50 pascals of pressure. And so what that's equivalent to is like a 20-mile-an-hour wind hitting all 6 sides of the house. So your 4 walls, floor, ceiling. So there's some arguments out there to say, well, okay, well, if we can get wind gusts up higher than that, that will disturb it. Okay, fine. But if, say, something were to happen or someone got sick soon after you left and did that, just don't put yourself in that situation.
Yeah. Good point. Okay, so first thing you do is just to review is you kind of decide whether or not whether you can put pressure, vacuum, or not do it at all. Okay.
Exactly.
And then what comes next? Do you have to seal off anything?
Yeah, so we really kind of want to leave the house in its natural state. Of course, we want to shut all exterior doors, shut and latch all windows, but we also want to leave all interior doors open. We want to get the entire house to that uniform pressure. So doors kind of behave like dampers. So if we have a door to a room shut, that room may not get to pressure like the rest of the house. So we want all that stuff opened up so it's got an even pressure throughout. And what I like to do, once I've kind of checked all that and it all looks good, I'll run the fan to maybe half pressure, so go to 25 pascals, and just walk around. Check that fireplace out, see if anything smells weird, is anything damp coming in. Is there a P-trap that's open? If there's a P-trap and there's water in it, you'll know it pretty fast. If you're depressurizing. Yeah, done that before. It's gross.
What's a P-trap? A toilet?
Oh, like your P-trap for your sinks. And showers and toilet, if they're dried out and you're just pulling in sewer gas, yeah.
Oh.
So you want to make sure you have water in those. Yeah.
Yeah. Totally.
So that's why I'll run it at half pressure and just kind of walk around and just use my senses and see if anything's off. And then once everything looks okay, then I'll take it up to the full 50 pascals.
Does the house have to be empty, or can you be living
in
in
it? Inside. Yeah, it doesn't have to be empty. People can be living there.
Will it like push stuff around like your,
No,
like kids' toys and stuff like you're saying ashes from the fireplace, like.
Yeah,
it's
because
like
the ashes in the fireplace is such a light thing. I mean, if they're not wet, if they're just dry ashes that are sitting in there, sure. I mean, that fireplace damper is not going to be sealed perfectly. It's going to pull air through that no matter what, and then pull it into the living room. But again, we're talking about a 20-mile-an-hour wind here, so a house is going to experience that, all throughout the year. So it's nothing that it really can't handle.
I don't know why Duke makes me laugh. So I thought of Weird Science when they put the party back together perfectly. It looks like I see Duke and I think of the 90s and I'm like, oh yeah.
Yeah.
But yeah, I mean, as long as those things check out fine, then yeah, there's really no concerns there.
Okay. All right. So then what happens next?
So once everything looks good, once you get a few of these under your belt, you can get the gear unpacked and set up in about 10 to 15 minutes. So once it's installed, you can install it in any exterior doorway. It doesn't really matter. If you put it in a garage doorway, just open up that garage door so you got air to pull through. And then, so basically you, on your manometer, it's a touchscreen, what we call a 2-channel manometer. So an HVAC manometer is going to be a differential gauge that really just reads, one pressure versus someplace else. This basically has 2 manometers built into one housing. So one is reading outside pressure versus inside pressure. That's how the blower door system knows when we've gotten to 50 pascals. The other side is reading the fan pressure. And so the way that works is, if we know the fan pressure, which we do, we're measuring it, and we know the surface area of the hole on the inlet side of the fan, which we do, it's the different settings are programmed into the gauge, and that's how you calculate flow. Back in the day, we'd have to do this longhand and figure out the math while we were there on site, and often get it wrong or screw something up. Now it's all built into the tool itself. So you tell it what setting you have the fan on, you tell it to go to 50 pascals, boom, you have your reading right there in no time. The fan really doesn't have to run very long. It gets under pressure immediately.
And is that these two holes that are open right here?
Yeah, so you have these different hole configurations here. So, if you can see mine, I've got 4 open because that's what it takes for me to get this room here under pressure the way I have it set up. But you can kind of think about it as gears in a car. So you have to keep a certain amount of pressure inside of that fan shell for the manometer to take a reading. If it's too open and the blades aren't spinning very fast, you're not going to really read a flow. It's just not going to pick up. So you want to choke it down so you're building up more pressure in there so those blades start spinning to enable to get that pressure there on that second channel.
Nice.
So on this house, if it's just 2 holes that are open, I mean, that's a pretty good sign that that's a fairly tight house. Most existing homes that don't really have much deliberate air sealing, that most of that fan is going to be open.
Wow. So it depends on your house too, because you're not, if you're now, when you say pressurizing, it's vacuum on the house, right?
Yeah, when you're pressurizing, you're pulling air from the outside and pumping it inside.
Oh,
so you're
okay.
putting the house under a positive pressure. Yeah.
Yeah. And so when you got this turning and you only got 2 of these holes, that means that house is pretty tight already, right?
Yeah. So
Or it
say
depends on the size.
Yeah. So, or it just depends on how tight or leaky it is. So say I start in this configuration, I start running the fan and I get to 50 pascals, but I'm not getting a flow. Say that 1.163 isn't there. I just have 2 dashes. That tells me that I need to choke it down some more. The house is tight. The other way around, the fan would be running wide open and I wouldn't be able to reach 50 pascals. That means I need to open it up.
Where is the 50 pascal pressure gauge? That's after the fan, like that's right on the other side of the door. Am I right?
It's actually on the gauge itself. So if you can see that tube there on the left at the top.
Is it in the
I lost your
in
screen.
the photo
there.
I had? Oh, sorry.
Yeah.
Okay, it's here.
And I can actually
Got something.
yeah,
there?
so that tube there on the left is reading pressure to the outside.
Oh, okay.
And then there's another port there beside it that's reading pressure on the inside.
Okay.
So we're using that outside pressure as our reference point to let us know when we've gotten to 50 pascals inside.
Okay, so that's between the two, there's a 50 pascal difference.
Exactly.
And what is the 1.163? That's how much it takes to make that?
The way this gauge is set up, that's 1.163 air changes per hour at 50 pascals. So that's how many times all the air in the house is turning over in 1 hour at that given pressure.
Got it.
In order to know that, though, you have to know the volume of the house. So there's a place in the gauge where you can input that. So say it's 20,000 cubic feet, you just enter that in, and then it does the rest of the math for you and gives you that reading in real time. That's how most state codes are written. It's written in terms of ACH 50. So in Florida, they're at 7 air changes per hour. They have to be at least at 7 or under. Other states are at 6 or 5. It just depends on where you are and what that code requires.
And is this 1.1 like abnormally good, or is that like expected?
That's pretty good. That's better than average. I would say average is roughly around like 6 or 7.
Oh wow!
I've tested houses that are over 20. These big historic homes that we have in downtown Wilmington, yeah, it's like a barn with the door open. But yeah, I would say that one's pretty good. When we're talking about passive house is the most rigorous building standard there is. Their standard is 0.6 ACH 50.
Like half of this.
Yeah.
Wow. So let's say you get your reading, and let's say it's like 20 or 25, and you're like, whoops, time to make some changes.
Or maybe see if there's a window open somewhere.
So in my case, it'll be the windows are closed, but there's still leaks. So now what would you do? like I see here the example, he's got like a heat camera. You talked about some smoke. What would be like your approach to I guess you're now on a hunt to find the problem. Am I right?
Yeah, exactly. So using a thermal camera, like you see here, what I like to do is put a slight negative pressure on the house. I usually like to do this before I run the actual test. And the reason I like to is I like to run the house at a lower pressure, like maybe 20 pascals or 15. I'm just exaggerating those leaks in the building just slightly. And then I can walk around with this thermal camera and just look for hot or cold spots depending on the time of year. So if it's summertime, I've got the house, to 70 degrees or whatever. If it's 90 degrees outside, then I'm going to see warmer colors come through those leaky spots. And the reason I don't want to ramp that fan up all the way to 50 pascals is sometimes it's tough to see where that leak originated from if you exaggerate it too much. Yeah.
Totally.
But the blower door and the thermal camera for finding leaks are a great pair. You're exaggerating those leaks, making them visible. The camera's picking them up.
Sam, I'm really glad you said about that little nuance about, hey, you might not want to ramp up all the way because once you saturate it, it's going to be hard to find the original part of it. I do that when I'm building something out of sheet metal or thinking about a design. I might make it out of cardboard, and the cardboard's going to exaggerate the problem. Obviously, I can't put as much pressure on the thing that I'm making, but it'll exaggerate it. I like subtle exaggerations. This way you can get to the problem quicker, cheaper,
Yeah.
Yeah.
And you really don't need a crazy high dollar camera. Thermal cameras are a lot less expensive now than they used to be. I remember the one that I used in grad school was this huge bulky thing, and it was like $20,000, and the battery looked like a Nintendo 64 cartridge. And now you can have them for $500 that attach to your phone, and really that's all you need. You're not really looking for great detail. You're just looking for those hot or cold spots that reflect air leakage.
So, keep in mind, I know nothing about this, but I'm just typing in heat camera, thermal camera. Look at this. I'm already down into the under 200 range here.
Yeah.
Here's 500, 400, 299.
Yeah, that FLIR one can plug into your phone, and then you use their app, and it turns your phone into a thermal camera pretty much.
Wow.
So there's lots of different stuff that's out there now.
Yeah, can you get an app on your phone?
Yeah. Oh, can you just do it on the phone, or do you need that different type of camera?
Yeah, you need that thermal sensor. That's all it is just a thermal sensor that plugs into the port of your phone. So they make them for iPhone, Android, and that's really all the resolution you need.
Duke, the T-Stud man is here.
There he is.
Nothing better than the red door of truth. I tell you what.
Mark, we need a thermal.
Mark, how's it going, man?
Sam, you are incredible, and welcome to the most incredible dudes on the planet.
I don't think we've ever actually met, so it's good to see you.
Sometimes I knock on your window, but then I run away. I'm always there, bro.
Just stick around next time. I'll come let you in.
All right. Sorry to interrupt. I'm just excited.
No, it's cool. I've been waiting for this day. This is the Red Door Truth Day. This is so cool.
So there are some conditions like Matt and I were talking about before. I like to usually have at least 10 degrees difference between inside temperature and outside temperature to really see what's going on.
But before you get into that, what do you think of this? This looks like bogus.
I've never heard of that.
It's too good to be true.
Couldn't tell you.
$176 for this thing? No way.
The brand that I've been using a lot is Hike Micro. I really like their stuff.
How do you spell it?
It's HIKMICRO.
Here we go.
Yeah, they got a really good Instagram account. I'm impressed by them too, Sam.
Yeah, they have a really nice high definition pocket cam coming out. I think it's already out now for like $600. It's awesome. It's the size of a smartphone, and you get a HD display, and it fits in your pocket. So the stuff they're doing is pretty cool.
I like that you could use it on electronics as well.
Sure,
That would be cool.
you can find all kinds of stuff.
Yeah, I want to know if I'm overdoing it for a processor or something like that. That'd be cool. I mean, I'm a car guy, but I'm getting into the electric cars, so I want to see about batteries and stuff too. So
Sure,
that's pretty cool.
We use them. We use them in our lab also when we're putting together prototypes. And have to keep an eye on the thermal conditions of the battery and the surroundings inside of a gauge or a fan or something like that. So yeah, we use them for that all the time.
Which one do you have here that you like? The pocket one you said.
I have. Let's see. Is that the EL1, the E1L? Yeah, I have that one. I'm kind of spoiled because their VP of sales lives 15 minutes from me, and we've become buddies. So whenever they have a new prototype of something out, I go pick it up and try it out. So that's usually what I've been doing.
That's
but
pretty cool.
I have their M30. It's a few steps up and has a high resolution. You can pair your iPad with it and have the thermal big screen on the iPad and record video that way on it. So I have some videos on our YouTube channel where I've actually done that, just recording video in thermal and pointing certain things out.
Nice.
Yeah, it's nice to work with a homeowner on that too. Like, especially if you get there and they're not home or they just leave a key for you, you can actually, go around that thermal camera and record the video and then show them later, like, hey, here's what I found. Here's what this means.
Oh, that's a pretty cool idea that you can record. Interesting.
Yeah.
All right. So now, so what do you do if there's not a big difference between inside and outside? Like you were saying, what if it's only 10 degrees?
Yeah, so that's when I use something like this. It's a handheld smoke machine. Basically, an e-cig in reverse.
Party.
Yeah, it's a good way to make an entrance too. But what I usually like to do is flip the fan around and then pressurize the house. And then what you can do is you can go around and shut some bedroom doors, and then discharge that fog near the door undercut. If it gets shot up underneath that door, then you've got some leaks in that room that you want to focus on somewhere. It's such a quick and easy way to find stuff. It just makes that air current visible. It's because it's going to push that air out through the leaks, and so it just kind of creates a trail for you to follow.
Hey, Ron, I just had my kids pull out the vape pen.
Oh, yeah. Just turn it around.
On existing buildings, Sam, do you pressurize or depressurize first? Because we were depressurizing the other day and all the water started coming in because the windows were so crappy. The depressurization brought water and it scared the crap out of me. I've never had that happen. So do you have
So is this on a rain day?
It was a crap window install.
Okay, so it had water sitting there, and you just pulled the rest of it in. Yeah, in that case, I would just flip the fan around and push that stuff out. We were talking earlier, in existing homes, you really kind of have to check stuff out. Like I mentioned earlier, fireplaces. If there's ashes sitting in there, you're going to pull that stuff in, and it makes a mess, and it's not fun to clean up. So I'd vacuum those out and then just wet everything down, just so you're not pulling stuff in. And then I mentioned earlier too, like for existing homes, if it's an older house that has insulation in the attic, I like to go and check to see if it's vermiculite insulation, because if it is, I'm not touching it. So I'm not gonna test the house at all. So yeah, existing homes are a little trickier because you really don't know what you're getting yourself into. So you want to go around and inspect some things a little bit more to see what you got.
Mark, what do you do with your beard when you're running the red door of truth?
Do I shave it real quick?
Grows back the next day.
It does. I just pull a string on my back and it goes. But I tell you guys, I wasn't on. I missed this episode, but Joe Konopacki was on, right? And we had a fireplace and a vermiculite story, and that is a true thing. Learning lessons. Well said. My beard. Come on, Duke. Shave it, just like high school.
I pulled up the vermiculite thing. This looks familiar. Like, I feel like this
Yeah,
is
I met this guy the attorney that runs this trust. He came to a conference we were at a few years ago, and I guess people just aren't taking advantage of it. So I think what it comes down to is a lot of cases they'll cover up to about half of the cost of the remediation that needs to be done. So it's a good resource to know about if you run into that.
Wow. I'm gonna go up to the attic, at some point and take a photo. And I can't do anything about it. I just rent here. I'm probably gonna leave here, move in the next 6 months to a year anyway. But it's interesting to know what's in your house. Even though it's not being agitated, I'm still sort of breathing this stuff because it's sinking down anytime the house gets a piece of wind through it, right? And the attic is kind of vented anyway. So, right, this come through the hi-hats and all that stuff.
Yeah, so especially over COVID here the past couple of years, I think, is my house making me sick? I think it was Googled 400 million times or something like that.
Wow.
And so the whole indoor air quality thing and what's actually in people's houses people have been really paying attention to it a lot. And so we've had a lot of residential HVAC contractors get into this mainly for that reason. So they can actually put together an educated answer to how their house is performing and what kind of air they're breathing.
Wow. Luckily, I was teaching remote, so I could. I left. I left the state. I taught from the beach for a little while there. That was good. All right, so we did that. Okay, so now the smoke machine thing. Get the kids to, you don't want them to vape, but if they're vaping, you could use that to your advantage.
You can go to the Halloween store and just get a theatrical fog machine. That'll work fine.
Oh, okay.
Yeah.
All right. So then I like that idea. Close the door. Bam. So you do that. You close the door and to that room. If it pulls it in, then go into that room and investigate further. Right.
Yeah, and you can narrow it down some. I've got one right here. This is called a pressure pan. And so you can have the manometer attached to this port, and then you can put this over receptacles, can lights, and if you get a pressure difference, that's an indicator that that's a leaky spot in that wall or ceiling. So there's some different ways to dial it down, even more granular as well.
That's pretty cool. I like that.
If you're a redneck, Ron, you use a piece of cardboard.
Yeah, you can make your own. You can make your own out of Tupperware and weather stripping. I've seen that.
I was thinking about like a gas can.
Yeah, I guess
That's on the boat. That's where we used to hide our soda.
What do? You cut the seam and it's
the
not
bottom out of it. Yeah. When someone comes and inspects your boat, especially in Canada, well, that's just a gas can there.
That's good. That's good. So, all right. So then now what other, okay. So now next thing is you found the culprit. Am I right? Or is there a step in between?
It depends on the leak. Sometimes you don't have to go in that much detail. Especially if you have the thermal camera, boom, there it is. You see it. So it just depends on what it is we're talking about. Usually we have more leaks in the attic than anywhere else. So that ceiling plane is going to be, there's more penetrations there, especially when you have your top plate and then your ceiling drywall where it meets. You've got a crack all the way along that wall. And if it's an interior wall, it's down the other side too. And think about how many of those you have that are adjacent to that attic space. So that can be pretty leaky. So going up in the attic, and then you can either spray foam the roof deck, or you can move insulation around and seal it that way. So there's a few different options of what you can do. Usually you're not going to be tearing out walls unless it's a full-on gut rehab where that's the plan anyway. But the good thing is that most of our leaks are in the attic and in the floor, and those are usually the two easiest places to get to.
Okay. All right. This is cool. And so now do they still do this calculation where let's say you pay for the audit or the blower door test, and then you get a baseline. I know they had this program in New Jersey a while back, and then you got a baseline. Now, if the contractor can get it up, make a 25% improvement, then they can get state funding. Is that still something that's going on?
Yeah, and it's a different number in different places. I think it's 30% in some places. I think I've heard 35% in order to get certain funding. So it just depends on the program.
I like
But yeah,
that
that's
you
exactly
measure-
what they do. These weatherization programs turn on the blower door and they pull out a thermal camera or a fog machine and go hunt them down however they can.
Nice. I like that they measure it, because it's like it's a measurable benefit. So you can see what they did afterwards. That's pretty cool.
Yeah, and these these manometers that we have now, they have a Wi-Fi antenna in them, so you can actually pair that manometer with your phone or a tablet wirelessly, and then it'll generate a report for you automatically. So you can do that pre-test. You got your number, and then you can go pull up that report later on and then see what that new post-test needs to be, and you can compare the two side by side without really having to write anything down.
Wow, this is awesome.
We're trying to make it easier.
Yeah, this is cool. So now, do you want to run us through some demos over there? Is there something you got for us, maybe?
Yeah, for sure. We can run it now.
I mean, even on the simplest, you got to keep in mind, I'm coming from no experience here. I've never even interacted with one of these. So it'd be cool if you turn it on, maybe just show us a little bit about it. I don't know.
You just said get a baseline. I mean, you're just talking like an energy expert. But Sam, remind everyone to put on their safety goggles and earphones before you get started.
Right.
Yeah.
Exactly.
That's true.
But yeah, we have a blower door set up right here. So for the purposes of this, let's just say I'm inside the house. The other side of that blower door is outside. We have it set up to depressurize. The inlet side of the fan is facing me. So let's just say I'm in the entryway of the house and out there is outside. It's just easier to show that way. But what we would do first, speaking of baseline, there's actually a baseline reading that we have to take before we turn the fan on. And that's when we would close up this inlet side of the fan. We can plug up the rest of these holes, or it comes with a shower cap cover that you can actually put over there. And then, am I able to share my screen right quick?
Yeah, sure. Go for it.
Let's see. What do I need to click on here?
There's an arrow that says present now next to the 3 dots. And if someone
Don't see that.
should be on the bottom there next to the hand, next to the red phone, the old school phone thing.
Oh, I see. Okay, gotcha.
Okay.
And how do I make Sam the full screen?
So Sam automatically is full screen if he's talking on the recording, but if you're watching him and you're on there, just pin him just by floating your mouse in the middle and then hit pin.
Oh,
Yeah, and that'll make it full screen for you. Or if it's not, you got to go
no,
to.
that's good. I'm new here.
That's okay. You got to go to change layout if you want something different. Yeah, this is a Google stuff. Okay, Sam, you're all set. Oh, I see.
Cool.
You're sharing now. Good. Okay.
So I'm just this is a program called Virtual Gauge. We use it to teach a lot, and so you can blow this up on a projector if you're teaching students. It's really great for that. But so this is that actual manometer that I have hooked up on my blower door. So once I have that fan covered up, I can go to settings, and then there's a baseline option here, and then I'll let that run for a little bit. And essentially what this is doing, it's just reading any pressure differences that are occurring between the inside and outside naturally, like wind or stack effect. I want to cancel that stuff out. So it's kind of like zeroing out a scale before you weigh something. So I would just hit capture baseline, and then, I let it run for 30 seconds. If it's a calm day, if it's a really blustery day, maybe I'll let it run for maybe a minute or so. So once I'm happy with the conditions outside and the duration of it, I can just hit in capture, and then
Wait, let me hit pause for a second, Sam.
Sure.
Mark, you got a question? I feel like you got you got a question. Your face looks like you got a question for. Oh, okay, all right. All right, is this coming through good for you guys? Can everybody see this? Okay, perfect. Okay, I was just making sure you're coming through and everybody understands. Sam, go for it. Sorry.
Yeah, so we can see that baseline pressure right here, that 0.1. I mean, there's not a
I
whole
think
lot.
I think you're not on the right screen. There's an issue. Hold on. When you go to share screen, you could decide to share a tab, or you could share your entire screen.
Let's see. I think I did entire screen.
I'm looking at your calendar here.
Yeah, we got two
Oh,
people
weird.
underwater.
These pretzels are
I
making
wonder
me
if it's sharing. Oh, okay. I think I know what it is here. Hang on one sec.
Okay. I'm looking at American Airlines flight.
Yeah.
This guy's on
I
the
do a
road.
lot
He's
of
like a
that.
rock star.
Let's see here. Stop presenting.
flying an airplane and doing a blower door test is actually about the same. Little known fact.
So if you're doing a blower door test on an airplane, you probably have more problems than just thermal breaks.
All right. Can you guys see this now?
Yeah, man. That's
Cool.
way better.
Alrighty. There we go.
Dude, we're in
So-
business now. This is 1,000 times better.
Right on. Okay. So y'all weren't seeing this at all before.
No.
Okay. Alrighty.
I was trying to
Yeah, but
read
one of-
your itinerary, and I was like, is that what he
Yeah.
wants to see?
My bad. Yeah, it was picking up a second monitor that I thought I had unplugged.
Okay.
Yeah, so what I did earlier to take that baseline was just go to settings, choose baseline, and then hit capture, and then just let it run, and you'll see that timer go. And so let's
Okay.
just say it's already run 30. I'll hit end capture. I can just tap the power button to go back home, and then now I can see what that baseline difference is here. Because this is
we're at
the
zero.
way we have
right
this broken up. This up here, the 0.0, that's called channel A. That's where our house pressure is going to be displayed. So that's when we know we've gotten to 50 pascals. And then of course here on the bottom is where our flow is going to be. So that example that you showed before was in air changes per hour. This will be in CFM, cubic feet per minute at 50 pascals. So once I've done everything, I've gotten my cloth pulled off. So,
wait, Sam, sorry to interrupt you, but
Yeah.
so I do some welding, and this CFM makes sense to me because about 20 CFM is what you want the argon to flow at when you're doing
cool.
So yeah, so when I see this, I can kind of compare. 20 is like nothing, what I wonder what these numbers are going to show.
Depends on the house.
Yeah.
So
Okay.
I mentioned earlier, instead of just if this is a house, an existing home I've never tested before, I want to start off at a lower pressure and then walk around the house. So I can just hit set pressure and then click 25 and then hit set. And so my fan is automatically turned on now. So I'm controlling the fan from my computer at this point. But this screen here is what you see. So we see we've gotten to about 25 pascals, but we don't have a flow yet, but maybe when we get up to 50, we will. So I can do a couple of things. I can just hit stop and re-enter 50, or I can just use these buttons on the side to jog it up. So I can see here on the bottom left that it's seeking 25. So if I just keep bumping it up to 50.
Cubic feet per hour. Sorry about that for the welders out there. Right? There's a welder
little
out there
different.
right now going, what? No. I fixed it. Okay, this is cool. Oh, you're almost at 50, man.
Yeah, so now I'm basically at 50. And then if I don't get quite to 50, I can just hit this button and it'll extrapolate it and just tell me what it would be if I could get there.
Oh, okay.
So 450 CFM at 50 pascals of pressure, if this is just a normal code built house, I would be stoked to see that. But usually what we see, what we would call normal is usually like a 1-to-1 ratio between the CFM 50 number and the heated square footage of the house.
Is that the blower is making noise right now?
Yeah, it's running.
Yeah, because you can tell the sound of your sound is coming through differently, but that's fine. I got you. Okay.
So turning it off, if I wanted to, if I wanted to represent it in air changes per hour, all I'd have to do is enter my volume. So let's just say, we'll just say 20,000 and hit set. And then I can just click on channel B here and select ACH. And then I can just run the test again. So this house, fictional house, would be 1.3, 1.4 maybe, which is, it's not passive house, but that's a pretty good number.
Yeah. And you've
It's
got
going to be a real world house.
They do a better job in Taylorville.
Taylorville's match
But
house.
that's kind of the quick and dirty of how it works. I mean, like I said earlier, once you kind of get a couple of these under your belt, you can set up this frame and cloth and the fan into the doorway in about 10 to 15 minutes. They just, all four sides of the frame snap together, and then you just expand it into the doorway, lock it in place, pull it back out, put the cloth on it, set it back in. You've got two crossbars, one at the top to kind of give you some stability, one at the bottom where the fan's going to hang from. And that's about it. Used to, what we would have is this red tube to go out and read our outside pressure. What we have now, we actually have the tubing stitched into the cloth itself. So you just plug the tube into the cloth and that's it. So you don't have to worry about it landing in a puddle or getting in the way of the fan and throwing off some weird numbers or anything like that. So, so that's one thing that's changed kind of recently. Used to, you had to, before you put the fan in, we call it the crawl of shame, where you have to kind of crawl through the hole and then toss the tube out to the side. So we've done away with that. There's no need to do the crawl of shame anymore. You just plug it up and roll with it.
This is wild. Now let's jump up. Sam, thank you for going through that whole thing. And you also have four of those holes open. And is that
so? Yeah, I ran the test before I hopped on the call just to see where I would need to be, so I'm not fumbling around. But if I'm going to use that automated app to generate a report, I'll run the test manually first, just to see what settings I need to be, and then run it again with the app connected to generate.
Does that indicate that that Matt's house is tighter than this little thing you got right here?
It depends. I just put in just kind of a random number for my volume, but this came in at 450 CFM. So do you know what your CFM 50 number is, Matt?
No, I only know the ACH 50.
Okay.
I'm still learning how those numbers correlate to each other and stuff. So
Gotcha.
I could run the test, and when we actually, when we do the next one here, if we do it tomorrow or Friday or wherever, I may run it and then message you and see. I mean, like I said, we run it as the ACH 50, and I understand what those numbers. Well, actually, I know what numbers we're supposed to be hitting and what's good and what not. I can't explain them like you can explain them.
Yeah, but Matt, you had your test taped, so Sam could actually see your screen from your IG.
Yeah. Well, the ACH 50, I think I don't remember the volume off the top of my head, the overall volume. I could check tomorrow though. Gosh, I wish I would. I want to say a guess, but I know I'll guess wrong. I mean, you might be able to ballpark it. We were
as a guess anyway, right? It's not rocket science.
16,000.
Can you? Yeah, I was gonna say I thought it was 16,000 something, but I can't.
16,324.
Okay. Yep.
Does that sound about right?
Yeah. It
Was
did
it
say
1,600.
Oh, maybe the square footage is just shy of, yeah, it's right around 1,600.
Yeah, leave it on that screen for a second. I can probably just mimic this.
Cool.
Disconnect.
Cool.
And then, by the way, is brilliance. The total
there's
brilliance.
A simulator I can use here to just kind of copy what you got and then change it and see what it is.
Dude, that's awesome.
So you're on.
Ron, I've never seen someone mimic it from afar. This is really groundbreaking. I've never seen this before.
This is cool.
You can actually if you accidentally run the test on set to the wrong setting, if you know what you got, you can use the simulator to go in and correct it to see what it would have been, so you don't have to go back and retest.
Whoa.
Oh my god.
Yeah.
Simulator. Wait, do you want to share your screen while you're doing that, or you want to
Yeah.
leave it like
Let me. Yeah. Hang on one
This is
second.
awesome. You know, the thing is that like I started life as a car guy, but I'm actually I just really like the science and engineering design stuff. Like to me, this is just as exciting as like turning out horsepower. This is awesome. Like what a cool thing that you're doing. It's like you're measurable, and then you can use your creativity to figure out how to make it better. You know, that's so cool.
It's
So
like
putting
woodpile
a house
in the
in a-
leaves.
What? Sorry. Wait. One. Go ahead.
I think we all
Duke,
talk same
Duke,
time.
go ahead. What do
Go
you?
ahead, Duke.
It's like putting a house in a dyno machine.
Yeah, totally right. It's a house dyno.
Like the plastic, the Moldorama.
Yeah.
Yeah. By the way, Duke, your wall looks funny.
Dude, update.
Oh, yeah. I know where's Zavaki. I'm going to try to hang this on the bottom of it.
Yeah. I had to trim down the Harbor Freight episode. I put it on a diet before releasing it.
Oh, watch out, Sam. Kevin Brennan's here.
Oh boy.
Kevin, how you
Kevin,
doing,
what's
Kevin?
up, man? I haven't seen you in a long time.
What's up, guys?
Welcome. How you doing?
All good. It's my first shop class.
Hey,
All right.
hey, Matt, what'd you say your volume was? Was it 16,000?
Yeah, what did it say, Ron? It was 16. I could probably find.
16,324 cubic feet.
So Kevin, what's happening is Matt is describing the test that he did down at the student pill home in Taylorville, and Sam is plugging the numbers in to his simulator to redo the test for us virtually.
That's pretty awesome.
I've never seen it in my life. I mean, you probably did it in high school,
What
Kevin.
was the ACH? It was like 1.3.
1.163.
Yeah,
Oh,
and that's before we hunted down leaks.
Right. And then you
So-
did it again, what,
So I
2
set
days
it to
later?
50 pascals on channel A because that's where you were. I've got your fan here, Model 5000 with the B2 range on there. And now I'm just plugging in pressures on channel B until I get the right ACH. So let's try like 175. So
And he had 2 holes missing. I don't know if that helps.
if I go back and, well, let's see here. If I go from there to CFM, so yeah, that's pretty low, man. 313. That's a great number.
Wow.
Yeah, that was before hunting. Let's say, and then I could probably pull up the.
Oh,
Let me
I
find-
got it.
You got the picture where it says 0.4.
Yeah, you got it down to 0.4122.
Wow.
Yeah. Built by high school students.
And we had one puck out, and I'll tell you what, it was having a hard time reading. I had to like put my hand over the hole real quick, let it ramp up, and then catch it.
Wow.
So while he's
Yeah,
doing
so to
this,
get down there, you would have to change ranges
Yeah,
to go to
like
B1.
yeah, it was having a hard time pulling it was having a hard time keeping a constant reading.
Yeah,
You getting there, you
that's
getting
tight.
close.
And if I go put in the CFM on that one, then yeah, 127. There's barely any leakage at all.
Wow.
Yeah.
That's
Yeah.
awesome.
Now, granted, full disclosure, even though me and Travis Brungart were talking, or not really talking smack, but challenging each other back and forth, he had all windows and doors in, and lighting and everything, and we had nothing but like our exterior doors. So it was literally a solid box, which is why we'll be running our second blower door test here. it maybe tomorrow, probably Friday.
Oh, so Matt, you had all the zip up, but none of the windows were cut yet.
Correct. Yeah. The only thing that was cut would have been the attic, or the crawl space hatch that goes outside, because the crawl space is part of our envelope. The front door and the back door. We didn't even have the garage door in.
Well, didn't you have all the drywall cans cut? They were
No, those still aren't cut.
Oh, okay. So that's your
Yeah.
lid.
Now, HVAC contractors have a hard time getting duct leakage that low, and you did a whole house.
No, I did it. The high
Yeah.
school kids did it. I didn't do nothing.
Is the air barrier at the ceiling or at the roof deck?
Ceiling.
Cool.
We do all interior framing inside underneath the drywall, pre-hung.
Cool.
Matt is doing that thing where the drywall is the air barrier. So half the people in the industry don't like him because they argue that, and he's proving that it is an air barrier.
You know, Matt, that's awesome. I've been kicking around the idea myself of using the fleece tape, that for me, the Proclima Asiga, as compound tape to be air tightness tape, and just compounding over it and seeing what it looks like. Because if drywall's airtight, why do we need all these crazy membranes and stuff, you know?
Yeah,
Yeah.
that's interesting.
There's so many more penetrations to the drywall too. I mean, the whole bottom, usually that's not sealed to the bottom plate. And then everything for receptacles and switch boxes and things like that, it's just, you're not going to get all that usually.
Well, like you said, Sam, when you have the interior walls up there, that's a lot of linear footage that you got to control.
Yeah.
So just so I understand, going back to the layman over here, Matt, you didn't put the windows in yet, right? Or they
Correct.
were in, but you didn't cut it yet.
It was just since we had the zip, it's green. So, but I mean, just an OSB solid wall all the way on the outside. So, no windows, just a couple doors popped in.
So this would be after. This is like you didn't even have this going yet.
Nope. All you saw was outside was a big green box.
Okay.
Cool.
And that's kind of cool because you're isolating it down. So like
Correct.
I like that. I like
so now
that.
we can go step by step. I mean, heck, if you wanted to get super picky, you could put one window in, do a test, put another window in, do a test. But I mean, we're not going to go that extreme, but we could.
But you did have this garage door open, right?
Well, that's out. Our garage is technically outside our envelope. Now we do have a door that goes from the garage to the house, which would be our, putting a hole in the barrier. But the garage technically we call outside, even though it's under the roof. It's outside of our air control layer.
So it would be like this, but with the roof on.
That's it. Yep.
And it is the attic part of the envelope?
Nope.
Oh.
It's considered outside. See, it gets confusing because people think outside is outside.
Yeah.
The exterior of everything, but when we're talking about this, it's outside of the whatever your control layer is, right? For us, in this instance, we are air barrier. So this outside would be above drywall and the ceiling above drywall. The garage there, that inside outside was a picture of where our garage meets the exterior or our wall. And then, but our crawl space is considered inside, and the crawl space hatch door actually exits out into the garage. So we did have to seal that off.
Cool.
And we have to address that. Now for that test, we just taped it. We do put in a gasket and everything, and that we'll also test and make sure that when we make our own door seal gasket or whatever, that it's working properly too.
That garage wall that separates the garage and the living space is super important to get tight because that's going to stop the car exhaust and everything from coming in. So that's one of the most important spots to seal up.
Yep.
Sure.
The other unique spot to show on this, I don't know which part of the reel it is, Ron, but for Sam and Kevin, obviously Nick and Duke have seen this, but there's a crawl space that then is accessed from the garage, and that crawl space services the kitchen and the 2 bathrooms and the mechanical. So while all the slab is foam and plywood, Matt's got this crawl space just for the MEP run. It's really unique application.
Is that in this one of these reels right here?
Keep scrolling down. You'll find a picture of like when we're working on it.
I
You're getting
remember
close.
you were taking-
Actually, I guess you gotta go up.
Okay, well there, like this is it you're talking about right here.
Oh yeah. There you go. You can see it. Yeah.
Yeah,
There's the crawl in the
that-
middle, and then the sides. Yeah.
yeah. And then I remember, let's see where it is. I don't know
Once
where
you
it
get
is.
past,
Maybe
actually, right
here?
there. That's there it is.
Yeah. There it is.
Oh wow, that's it.
And,
Yeah,
and
that's
that's inside the envelope, right?
Yep.
Cool.
Very
So that-
comfortable. Very comfortable place to be.
Yeah.
And how tall is that? What are we looking at here?
From floor to bottom of joist, it's just a normal 4 foot.
Oh
It was
wow.
5 foot total, but
Are you like you're like kneeling down when you're doing this or something?
oh yeah.
Well, and at the end of the crawl space, there's a door to the garage. So that's a
Yeah.
whole other lineal footage of possible leakage. So you're adding
Yeah.
the volume to the space, but you're also adding the risk of a door. So that is something that was really well done by you guys to make sure it was sealed off.
Yeah. Now for that first test, we just taped the seams around that door. But yeah, but I mean, on the other house, we had the same thing, and we finished off the final blower door was 0.9 on the last house, and we had the same kind of garage door hatch or a crawl space hatch going into the garage door. So
Interesting. Oh, I know. This goes into the garage. Like, how does it go into the garage? Oh, because the garage is at a different level.
yeah, it's just there's a pit, like it's concreted off, and then we'll actually this one. The last one where you just sat down and screwed it in. This one you actually drop. We'll have a built-in ladder where you crawl down and duck and walk in. I need to take a picture and show it. I guess
Yeah.
it's
Like,
hard
where's the garage here?
Okay, see where that guy see where the student in the black is holding the tape measure? Where
Yeah.
he's right there. Literally, see how the wall behind him kind of dips down?
Ah. Okay.
That's where it is, right there. He's standing in what will end up being he's standing
The
right next
door.
to the pit that goes to the door. Yep.
Got it. And this is the garage
Yeah. Yep.
floor right here.
Yeah. That.
Okay.
Yeah.
And that gets a slab as well, right?
Yeah. And they got a slab. Yeah.
Okay. But this doesn't look like it right now. But that's a slab.
Correct. Yeah.
Okay.
So like if you're in our garage right now, over in the corner, we put a barricade up so nobody goes over there and falls into it. But yeah, it's just a concrete pit. And
Yeah.
then
And that's
with
where
a
you put
door.
mechanicals and whatnot and stuff like that.
And then you go down in there, and then you can get into. It'll have some probably a little bit of ductwork down there, and it has all our plumbing.
Okay. And you need this for the plumbing and for the ductwork. Otherwise, it's going to be in the house with you.
Yeah, it gives you a little bit more room for that. Or otherwise, the plumbing would all be underneath concrete. But instead of having an entire open crawl space like we had last house, this is something Jake Bruton and Steve Basic had done with a basement. We just kind of modified it and did it with the crawl. So we now have storm shelter. You have storage. But we have to, for the sake of what Sam does, we have to include it inside the volume of that crawl space gets added into that volume that Sam typed in for us.
Got it. Okay.
So we have to factor
Cool.
that in. Yeah.
That's cool.
How do you guys condition that space? Do you have a dehumidifier serving it?
We put a dehumidifier in it, like just a plug-in one, and let the drain go into the sub pump. But it will have it'll have its own like return and vent supply.
Gotcha.
It's just it's just a very short basement.
Cool.
Gotcha. Really cool. Now,
Sam, what I was thinking of, because Matt did this test with the full zip on, right? So he has basically an envelope test. Now that he has the windows in, it'll be an envelope with glazing penetration test. That's a comparison that not everyone does. Typically, Ron and Nick and Duke, they'll do the test pre-insulation, say, but the variance of knowing before and after the windows, now you actually have a study on the window glazing and frame to wall sealing, or if that's done right, because Matt's meticulous and has a lot of good tape, you might get the weakness of the window itself showing the variance compared to if we didn't have windows and it was just all solid air barrier zip. Make sense?
I'm sorry. I was actually looking up Kevin here. Mark, tell me that one more time. I'm so sorry.
Oh, so Duke and Kevin and I, we went to high school together over in Staten Island. That was way back. Same softball team. Kevin didn't like me, but him and Duke were pretty tight.
Same wrestling team too, and we used that smoke from the red door as our entrance.
Yeah,
but I
sometimes
see-
we put that in Shiloh.
That Ron, all Mark was saying was, and the quick version was, since we did a blower door test with no windows, and now that we put in our window, we could test and verify how well, or we can see if the windows themselves even leak, like the unit themselves. And
Do you still have the red door?
oh yeah, we own one.
Oh, dude, that's
Yeah.
great.
In fact, so it's nice, like Sam was saying, we just left it in its frame and everything. You undo the cams, pop it out, set it off to the side. And so since I have multiple, 2 different class sessions, we just pop it out, shut the door, go, whatever, do lunch, come back, next class comes in, pop it in real quick. But yeah, once you get used to it, Sam's right. It's like even setting it up from scratch, especially on new construction where you don't have to worry about running through the house and doing this or that. It's quick and easy, man.
That's cool.
People ask to borrow it for like the weekend.
They haven't yet, but I don't know if there's anybody else in town that knows how to use them. So
Have any students ever taken it home just to test their own houses to see what they are?
no, some of them said something about, I wonder what my house is. I've never brought it home to my own house, probably because I don't want to know, but we have had a blower door test done. I just never saw when we had an energy audit, like our energy company was doing, where they come and seal things up for you. And I know they've made a difference because after they did it, and we have some air leakage in our can lights in our master bedroom, because on a windy day, if you open the door, they'll whistle. And so and the thing is, it's a vaulted ceiling, so it's hard to get to. And I'm like, gosh dang it. If I knew things back then, 8 years ago.
The shoemaker.
Hindsight's always 20/20.
Oh God, yeah.
So I was listening to IG this weekend, Sam, and I saw that you guys have something different than a shroud. You actually have a panel as well for the red door of truth. Never knew that in life.
That's actually what we came out with first back in the 80s. It was just the hard panel. And instead of having the frame and cloth, it's just you have a panel that you put in at the bottom of the doorway. The fan will go into that. Another panel on top, another panel on top. And then it's not, it's that video. That's what it is right there. And it expands in both directions, so you get a good tight fit into the doorway. There, I'm just explaining that you have a cloth that here's something different. And you see those little yellow straps. You can pull those, and that's what's going to pull that panel snug into the doorway. This is a little bit leakier than the framing cloth. I mean, if you put the panel system in correctly, at 50 pascals, it's about 14 CFM leakier, so not a whole lot. But if you're shooting for passive house, I'd use the framing cloth, because at that point every CFM matters. So, but I mean, this one it's a little more to carry around, but it sets up a lot faster. You just pop it into the doorway, one panel, pull them snug, and it's up. So it's personal preference really, and what kind of test you're doing. It's just
If you
another
have
way
a
to do it.
Dutch door, then you only need the bottom sash.
If what now?
So the Dutch door, you could open the top of the
Oh
bottom.
yeah, yeah, that's true.
So there
I've
you
never
go.
seen that done.
When you build your house next time, Matt, make it a Dutch door, and then there you go. You can do a blower door test till the cows come home. So this part right here is the part I like. It goes in and then it twists and turns tight, like I don't know what, like a mason jar. Amazing.
Yeah, the very top of the lip of the fan is a little thicker, so you turn it to the side a little bit to get that thin spot to make it pop in easier, and then you just turn it back. So yeah, it's pretty easy.
Tighter connection.
What's that? What are you saying, Mark?
I was just saying on the panel one in the video where the fan hits the perimeter, that particular area seems tighter than a shroud that like
Yeah.
behind Sam's left shoulder.
It is. There's a piece of weather stripping in there too to seal the lip of the fan to the panel. But yeah, but it's just where you have the different pieces of the panels meet. There's rubber seals around each panel, but still you'll get some little gaps and cracks there in some spots, and that's really what makes it a little leakier.
Is it because it's hard? Is that because it's hard?
It's just because it's not one monolithic piece. It's several pieces together, so it's tough to get a perfect seal between each piece. So that's what makes it a little bit leakier.
Whereas the bag version is one piece.
Yeah, that's why the cloth is tighter, because it's all one piece.
So it's not the edges that's an issue; it's the panels going together.
Yeah,
right?
it's usually like where the panels go together along the edge. So you've got doorway and two panels meeting, and usually there's going to be a little hole there.
Okay, I got you.
Yeah,
I do
again,
appreciate
we're just talking about 14 CFM, so not a lot.
Yeah.
But again, if you're building houses as tight as Matt is, then yeah, you want every CFM to count.
I could see why someone would want the hard door, because like you're saying, it kind of looks like more professional. You show up with a bag.
Yeah.
Maybe someone's like, "What's this hippie energy guy doing?" But maybe, I don't know, but that's probably a thing of the past. I mean, if they hired you, they probably, I mean, you got numbers to back everything up. So, I mean,
Sure.
I don't know. It looks cool, but you're right. Like, the bag works better because it's one piece. So, how does it seal though with the bag? Like, it's just a bar pushing on it on the rubber or something.
On the cloth.
Yeah, like the cloth. Like,
Yeah.
how does it touch the
Yeah,
door
so
frame?
around the perimeter of the frame is a piece of rubber weather stripping. So it seals it into the door. And then whenever there's these cam levers on each piece of the frame, whenever you push them down, they tighten up.
That's cool.
Yeah.
So
It's just two different
now-
ways to do the same thing.
Yeah. Now, while we got him here, we also have Kevin here. I haven't met Kev before, but I pulled up. Kevin's part of Passive House. Is this the right guy?
Ron,
Yeah, and I
Is-
think
is
Kevin
Kevin
just
still
left
here?
too. I think he just left.
What?
Ron searched the internet and did a blower door test on Kevin.
Yeah. So Kevin, I met Kevin at the very first Passive House training for tradespeople in New York 10 years ago. Kevin's from Staten Island. He's a New York City fireman, and his company outside of when he's working for the ladder is Brennan Air Tightness and Insulation, and that has a IG page too. And where Sam and Matt probably know him is he's really big on testing buildings and doing the air tightness and insulation on top of it. Almost all of his projects are for Michael Ingwe, Baxter Ingwe Architect, who's the founder of Passive House Accelerator. It's a pretty close-knit community when it all shakes free.
Yeah. Well,
Kevin knows more
saved our
about
butts
cellulose
one time.
insulation than anybody I know.
Yeah,
Oh,
he's
yeah.
a connection.
Is this
He
Kevin right
saved
here?
us one time. We had a big commercial building test in Queens, New York one time, and it took 33 of these blower door fans to test that whole building. The building was 1 million square feet. And so the company rented a bunch of fans from us, and then the delivery truck got caught in a snowstorm. And so we were scrounging for fans, and then Kevin pulls up and drops all of his off for us to use. We got it all, that was, one of, or I think he dropped off 3 out of the 33 that were used that we were able to scrounge around and get that test done. And then, yeah, he came back around and picked him up. That was the first time I ever met him. He saved us that day.
I think I saw a photo of like this enormous garage door with all these blowers in it.
Yeah, that was probably it. We had 18 in a garage bay door.
Oh my God.
It's
You
on
just
our,
passed
if
it,
you're on
Ron.
Facebook,
Oh,
we have
it's
a,
not?
there it is. Yeah, scroll
Oh.
back up on the left.
Oh,
I saw it.
here?
Where did you go? Nope. There it
Oh,
is.
wow. Yeah.
Yeah.
Wow.
So we have our Facebook group as well, fans of Retrotec. So if you're on Facebook, feel free to join that. It's open to the public. But yeah, that's the
Oh,
cover
that's a
photo
great-
for it. So there was 18, and then we had a group of 9, and then 2 groups of 3 up on the roof of that building. So that was by far the biggest test I've ever done.
Whoa.
So on the commercial ones of that size, is that also pressurization and depressurization?
Yeah. So usually what you're going to do is you'll test the ASTM E779, or you'll do the Army Corps of Engineering standards. And what they do is they require you to test in both directions, and then you take an average of the two.
But for military applications, I know you mentioned Army Corps, but military buildings are done at 75 pascals, right?
Yeah, all commercial buildings are done to 75. And then
Well, all
military
commercial.
buildings they're all done to the Army Corps of Engineer standards. And that's the way that they measure leakage. They don't use air changes per hour because it's not air changes per hour it's handy, it's easy to understand, but it doesn't put buildings of different sizes on an even playing field. So it's easier to pass a larger building than it is a smaller building. So what they do is they take the whole building envelope area and they determine how leaky that building is per square foot of envelope area. So the Army Corps of Engineers is 0.25 CFM per square foot of envelope area. So you have to add up the square footage of all 6 sides of the building to get that number.
So here's an interesting point. The fans do what they do, but there's a lot of potential for human error adding that up. Like 6 of us could have tape measures and clipboards to come up with different surface area, right?
Totally. With a building this big, I mean, there's a little bit of wiggle room there, and how much that's really going to matter. A lot of times you can get those measurements off of plans if you have that. So this was a federal building, so we had access to plans, and so we can make the calculations off of that. So having the plan really helps if you can get your hands on that.
Gotcha.
Yeah, you're reliant on proper information because if 4 separate groups measured it, they might be implementing that data, and then that variance, like you're saying, because the volume is so large, is almost nominal.
Yeah. And usually when you do a commercial test like this, you're going to have plans. There's going to be plans somewhere, whether if they're on file in the building itself or with the builder. There's a lot of new construction testing going on now. It's required in some states. I know Washington State is really starting to require it for all of their commercial buildings starting pretty soon. So yeah, with new construction, you got plans. And so you can just have software do all that for you.
Nice.
That's critical.
Yeah.
Now, I noticed that, like you said, Kevin's in Astoria. I'm not far from there. And the other woodshop teacher is Kevin Witt, and he's building a house, but he's got no roof on it. So it's kind of like a tiny home inside of the wood shop. So it's not really a house, but he's playing around with different walls. And maybe we could work with Kevin to borrow his blower door, and maybe he'll come down and give us a demo.
So in lieu of the roof, in that case, since it's a 5-sided box, right? You have the 4 walls and you have the floor. What they would do is, I'm assuming, take some, like 6 mil or 8 mil plastic and tape it and have that be the mock roof. Is that right, Sam?
Yeah, you could
This
do
is-
that just to
you
get an
know,
idea of what it would be. Yeah.
Right. So the students are learning construction. This is the image. Can you see that on your screen?
Yeah.
So you want to describe what the program's trying to achieve, Ron, so that he
Yeah,
can
they're
hear
just doing. It's the first time they're testing out like a house construction class. But the thing about it is that we don't have that much space. It's not really a high ceiling. So he's just doing like different walls. So like each wall has a different type of stud and a different type of insulation that they're going to put in. But he's got no roof, but he does have a floor. It'd be pretty cool to do a blower door test on it. I mean, I don't know. Maybe Kevin is, he might not be like ready for that next thing. But I'm like, well, if the guy's in Astoria, it's not that far. We're in a town called West New York, and it's I know that sounds funny, like we're in West New York, but it's actually West Manhattan, and we're in New Jersey. Like, if you ever knew where Sully landed his plane, we're kind of like we like watched him land his plane in the Hudson, like like not in real time, but once we heard about it, everybody ran outside, and there he was. We're basically right there, right off the Hudson. So, and Astoria is just on the other side of Manhattan. So he's only like an hour away, maybe an hour and a half in traffic. So it'd be pretty cool if he came in, gave us the thing. I mean, I'm offering his services basically. But no, that would be awesome. So, and I bet you he's got a lot of business out there in New York area, because now it matters how much energy you're using, whereas in the past nobody cared.
Sure.
Ron, then you could tape that plastic roof down with that Huber wood stretch tape.
Yeah. So basically,
Yeah,
we could
totally.
just do a plastic roof and just pull it tight, and we're done.
Well, you'd have to tape the seams down or embed it in caulking or something. And then you got the window openings. You'd have to do the same kind of covering. Like you'd have to mimic sealing the roof, sealing the windows.
All right.
Obviously, one door would, the one door, whatever, would be where the shroud would go. But yeah, they could do it technically. They just take a little bit of work, which I guess they'd learn some. The kids could learn some air sealing details with tape and stuff.
I say let's do it. I want to make this happen. I think that's a cool thing.
And it's one of those things where they could go with, since it has sheeting, what happens with no tape seams between on the sheeting, and then if they tape the sheet, the kids, because then the kids could actually go looking for leaks, because it probably would leak. Then they can see where it leaks around from the wall to the foundation connection, where that's another, anywhere. I mean, Sam will tell you, anywhere where you turn a corner, it's usually where you got to deal with these details.
There are leaks that you can't really see, especially in the corners.
Yep.
I mean, you look at it and you're like, that looks tight, but then you find out it's not.
Yep. Well, that was just like with us, and that's where almost all our leakage was coming from. Whenever the kids were running the what was supposed to be a continuous bead of caulk, where our drywall pushed up into this, I call it air sealing plate. We either just didn't get thick enough or whatever, and that's where our leakage went. So we went around and just ran a bead of caulk all the way around the perimeter of the house up top, and that's what took us from 1.1 down to 0.4. Or actually, the 1.1 we didn't have the attic or the crawl space door taped off. That took us down to 0.8, and then they went around and went from 0.8 down to 0.4.
So that's the coolest part for me, is if you just have a building that you're testing for the baseline to see where it's at, and then you're going to be doing work. Okay, that's where it's at. But for new construction, the blower door is a tool that allows you to fix all the other spots before you start your next phase. It is quite possibly the best tool that will make the biggest difference to help you achieve the rest of your goals. I don't know that there's a better tool that makes a bigger difference.
And if you're using it to solve problems, it's also a great teaching tool.
Bam.
Yeah.
Yep.
There's your sound.
You can
Right down the time, Ron. There's your sound bite. Duke scored again.
Yeah, really.
you can measure and expose leaks with it. So
Absolutely.
it's a kind of a 2-for-1.
This is awesome.
It's all about
cool.
solving problems. That's what they teach in school. That's what they want you to teach. You know, it's tech ed in a nutshell right there. And exposure. I'm sure it takes a unique person to show interest in this red door of truth, you know, to want to, you know, look at this as a career option. But, you know, if you get someone's interest in, you know, these new businesses or new buildings are looking to have blower door tests like this, you know, there's a route for kid to go.
Well, I think the energy and the comfort side is great, but I think a really important factor here is the health aspect of it. We had a customer in Oregon. It was a family of 5. They all had asthma. They were all on asthma medication, feeling horrible. And this is an HVAC contractor. He came in, did the blower door test, did an air leakage test on the duct system, and was able to find out that there was a very leaky ceiling plane and some very dusty cellulose insulation. And there was enough return leakage in there that was pulling dust from all of this attic insulation through the distribution system that these people were breathing in. So he found that pretty quickly. They went in, they air sealed the ceiling plane, they sealed the ductwork, they got the airflow right. I think 4 out of 5 of the family members were able to get off of their medication. And I think they saved $7,000 a year in medical bills after that. Wow. It's that stuff that shows the importance of why we care about this. I mean, we had a similar story in Greenville, North Carolina. There was a lady had horrible asthma. House was built on a crawl space. There's actually 2 really good energy auditors that work for the utility company there in Greenville, and they found that the crawl space did have some mold growth. She couldn't afford to do a complete encapsulation, but she could afford to do to tighten the ductwork in there, so to stop pulling those mold spores in through the return and out to the supply. And then her symptoms were cut in half after that. So just seeing those impacts just from the health standpoint I think is super important. This is not talked about enough.
Interesting. Now we've got on Kevin Brennan, his, like, this is kind of from the Google search. This is his business, and he's got a whole bunch of photos here of him using the different techniques. But something that came up, and you guys mentioned it a bunch of times, is the ductwork, which I feel like we didn't really get into that much. But basically, you're doing something similar, like you're pressurizing the ductwork the same way you do the house. Am I right? Or is there anything?
Yeah, it works the same way. Uses the same manometer. It's a smaller fan. It's a calibrated fan similar to the blower door. Has that flex duct that you would attach to the duct system. It looks like I don't know what he's doing here. He's testing something commercial, but usually you would use this in a residential scenario. You would attach it to the main return, and then you have this tape. It's kind of like a saran wrap on steroids. And then you would use that to tape off the rest of the returns and supplies to completely seal off the system. But instead of 50 pascals, we test the duct system to 25. That's all it takes. And then what we usually do for residential properties is we look at it as a percentage. So we want 6% duct leakage. That number is going to be 6% of the floor area that system serves. So if it's 1,000 square foot floor area, then 60 CFM at 25 pascals is what we're looking for.
Okay.
But yeah, that's it. It's just a smaller fan.
Cool. Interesting. All right. This is awesome, man. I feel like we now let me give you like a closing kind of setup here. Let's say you were a shop teacher. Is there anything you'd want your students to know fundamentally wise? I mean, of course you could do a blower door test, but what are some fundamental building techniques or skills that you think your students your students would want to know. Basically, what advice would you give a shop teacher who's going to do stuff like this? What do you want them to teach?
Just go find Matt's page and do whatever he's doing. I mean, I think one thing that's important though, like if I was a shop teacher, is to show that there's absolutely nothing wrong with going into a trade, and you're actually probably smarter than some of your classmates that are going to college. Especially if you find something that you're really passionate about and that you care about, that you can do a really good job with. It's extremely lucrative. I mean, right now, even before COVID, the amount of new tradespeople coming in compared to the amount going out and retiring is way lower. So, and now we know how everybody's looking for workers now. It's even worse than it was before. I mean, it's kind of crazy not to go into that direction out of high school. And, you know, it's gotten a lot cooler than it used to be. I mean, the tools that are out there now, there's all this Bluetooth stuff that works with software. You can find problems so much faster. If you just kind of stay on top of the latest trends, there's so many free resources out there that you can find to really see what the best out there are doing, whether if we're talking about HVAC or home builders, insulators, everybody wants to share what they're doing, and it's all out there. So I would really push to consider that.
That's awesome. Yeah, well said. Thank you for saying that. You know, it's to me, it's interesting how basically the schools are trying to make everything two-dimensional, but really the world is three-dimensional. And so, you know, whether it's 4D because it's time as well and temperature. But so when things are when students understand how to work in three-dimensional, so whether it's like encouraging them to work in a trade or encouraging them to work with their hands, you've broken that dimension. So now they're not just reading books and then have really soft fingers and they've never seen failure, you know, because the books, they never fail. They're perfect because they've been edited. That's an edited, curated world. Whereas the three-dimensional world is quite scary. Things break, materials break down. Mold can destroy wood. Vapor and moisture can destroy the wood, and not everything is straightforward where it's like edited like a movie. So the three-dimensional world is quite scary, and they don't want to push students towards that. But that's the only world we live in. We don't live in a two-dimensional world, so it's quite ironic that the schools are always pushing a two-dimension everything. So whether it's the trades or not the trades, I just think people need to start working in 3D. You know, so that's my 2 cents. But I think you said it really well, and I appreciate you saying that because it goes a long way when a shop teacher hears that, and then or like a parent, they could listen to this or watch this podcast, learn something about. They don't have to do this, but at least you touched upon it, and now they understand something. You know, like I don't build houses, but now I know something about it. At least that now I know the stuff in my attic I shouldn't be breathing. I didn't even know that was a thing. You know, I suspected that. Yeah. Well, this is cool.
We're always teaching measurement, you know, 16ths, eighths. Now you got to look up what a Pascal is a form of measurement.
An inch of water.
Oh, is it that it pulls an inch of water?
Yeah, I mean, most trades know pressure as inches of water. I mean, that's how we measure static pressure in HVAC systems, things like that. There's 250 pascals in 1 inch of water. So once you tell an HVAC contractor that, like, oh, okay, that's relatable. So
interesting. That is cool. I just looked up Pascal. Unit. Wow, that's cool.
Nick, you went to high school.
Small unit of pressure.
This is awesome. Well, let's kill the recording here. This is pretty good, and then we'll probably hang out for a bit. Anybody want to add anything before we wrap it up?
I just want to say thanks for having me on. This was a blast. This was a ton of fun. Great discussion.
Oh, I'm so glad you had fun. I was looking forward to this. Sam, thank you for doing this. And I'm sorry I had to cancel the other week. Yeah, that was a crazy week. But
no worries.
Okay. Nah, this is great. Anything else anybody wants to add? All right, we're good. All right, so Shop Class Podcast. We had Sam from Retrotec. Check it out, and we'll get the audio version of this going soon. And see you on the next week. All right.
Cool.
Okay.